Hello everyone, good evening. My name is Vedant Singh, and in this recitation video, we are going to learn about data processing for image datasets. If you've seen in the previous recitation videos, we spoke about dataset class and data loader class, and we also spoke about how to do data preprocessing for audio datasets. Now, this is going to be data preprocessing for image datasets. We spoke image data preprocessing is actually a very essential step in the ML and DL pipeline. It is ensuring that the model learns and is exposed to the most important, most relevant features of the data set for that particular task. That is why we do data preprocessing essentially. So say we have an image classification task or a speech recognition task. We want to ensure that our data set has the most important information, the features that is responsible for image classification of speech recognition, and the model is able to learn from that. So in terms of data preprocessing for, say, data set that has images, let's see how we can do that. So first we import the most important libraries, which is going to enable us to load those images and also then pre-process them. So we load in one of the most open source large data banks, such which is Lorem Pixum. We load certain data points from it. Now, it is very essential that all of our image in the data set is of the same size. We don't want different size of images in the data set. It is an unnecessary information and creates unnecessary problems for the model to learn. Thus, we will resize all these downloaded images of this into same size. Your standard size of the image are 128 cross 128, 224 cross 224, along those lines. We are going to do 224 cross 224. So after resizing, we are going to conduct now exploratory data analysis and visualization of that data. We load the data set from our directory and we plot the data set. This is how the visualization looks like. Like I mentioned, our data point is actually an image. So these are several different images having information of its own. In essence, mostly it's pixel intensities. Like for example, like RGB values. So we want at each pixel what is the R, G, and B values. This is each image, each pixel will have that kind of an information. Now, in terms of data transformation, like we mentioned in the earlier videos, data augmentation, data transformation is very much necessary so that our model does not overfit. It becomes robust. It is able to handle different types of data. That is our main goal while data transformation. So like we did for audio data set also, first we are going to be normalizing our data set. We are going to be calculating the mean and the standard deviation of the images and convert all of the data set and scale. More than convert, you're going to transform and scale that data set to that particular mean and standard deviation. So first we calculated the mean and standard deviation of image in the data set, and then we have scaled it. We've used these normalization and standardization techniques to transform it to that particular mean and standard deviation value. So after doing that, we can see that if this was our original data set, this is how our data set will look like after normalizing it. So this is the mean and standard deviation of it. Okay, this is how we are going to particularly do that. Now, in terms of data augmentation, PyTorch allows many methods for data transformation. It is on us to carry forward with the most important data transformation techniques. So we've given some examples, like say a random horizontal flip. Now this will actually keep your original data point, like your original image, and also flipped image of also your flipped image. So in this, we are randomly going to do an horizontal flip. The argument p equal to 1 means that if all of our data points, like 100% of our 100% probability of our data points or data set, we want to we want to do a random horizontal flip. That's what it essentially means. We convert it to a PyTorch tensor, and this is what we get. We flip it horizontally. So this is how we are possibly going to get. There are multiple augmentation strategies that can be applied. Like out here, we just did one. We can combine many transformation augmentation techniques, and we can make our information image much richer. Okay, so this is after you resize it, you do a horizontal flip, You play around with your brightness, your contrast. You basically a random affine, what it does, it basically transforms it, keeping the center invariant. We transform it, like we rotate it by 10 degrees, and we also translate it point 0.1 by point 0.1. And we scale it also. These are different augmentation strategies, just so that our model is able to learn the most important and our data set becomes richer. Now, what happens sometimes is that in all of these transformation techniques, sometimes the model is actually not able to learn important information. Sometimes the important information is lost. So it is on us, it is on our experimentation and ablation methods that we decide what all data augmentation techniques we need. This is something that y'all are going to experiment with in your homeworks. This is something that is expected of y'all. Y'all need to understand that which augmentation strategy worked for which task correctly. Now, for example, let's say we have a facial recognition problem. We want to, from the image, be able to facially recognize who this person is. In this kind of a problem, it does not make sense at all to do a vertical flip. Now, if this is our data set and we do a data augmentation where we are vertically flipping, in this, the model is actually going to lose information. It is not going to be able to understand how to recognize a face or how to map a particular face with a particular person. So random vertical flip will be a wrong data augmentation technique in such a scenario. So you see, you guys need to decide which strategy works the best. Now, this is all about pre-processing of audio and image. This is the two of the most important data sets you all will be working with. Um, if post this, we want you all to go over these questions, understand that you all see that if you all understand these concepts well. If not, you all can come to the OH anytime. All the TAs are ready to help you all. But this will actually test your understanding that have you all completely understood these pre-processing concepts in terms for audio and image data. Thank you very much. That's all.